All right, good evening, everyone. We're still on week 22 of our Bedrock module. This week we have been learning about RAG. For day 3, we will be getting into RAG evaluation and automated testing in CI/CD. We have one lesson, one lab, one challenge, and then TLOs and ELOs. So for TLOs, we're going to be implementing comprehensive RAG evaluation using Bedrock as a judge to measure faithfulness, relevance, and precision with weighted scoring. We're going to be building automated CI/CD pipelines that run quality evaluations on every code change and track metrics over time. For ELOs, we'll be explaining why systematic evaluation beats runtime validation for production RAG systems, implement faithfulness scoring that detects hallucinations and unsupported claims, implement answer relevance scoring that catches topic drift and off-topic responses, implement context precision scoring that measures retrieval quality, combine metrics into weighted overall scores with configurable importance, build test suites with query categories, expected keywords, and minimum score thresholds, create PyTest test files that assert on quality thresholds and fail on regressions, configure GitHub Actions workflow with push, pull requests, and schedule triggers, track quality metrics over time and analyze trends to detect gradual degradation, and implement evaluation caching to reduce bedrock costs on repeated test runs. For an overview, yesterday you built self-RAG systems that validate individual responses, but validation at runtime isn't enough. You need systematic evaluation that measures quality across many queries, tracks metrics over time, and catches regressions before they reach production. Today you'll learn to evaluate RAG systems using Bedrock as a judge, automate quality testing in CI/CD pipelines, and optimize performance and costs with caching and tracking. Now, what are we trying to accomplish? We aim to transform quality assessment from intuition into data while establishing continuous monitoring. By the end of this session, you will understand how to measure faithfulness, relevance, and precision using Bedrock as a judge, build test suites that evaluate quality across multiple query categories, and integrate automated evaluation into GitHub Actions for every code change, track quality metrics over time to detect drift and regressions, and optimize evaluation costs with caching. You'll have measurable, trackable quality and not just guesswork. Before we get started with the lesson, any questions? All right, let's get started. So RAG evaluation and automated testing in CI/CD. The evaluation problem. Your self-RAG system validates individual responses, but how do you answer these questions? So we have 4 questions on the table. Our first one says, what's our average answer quality? Self-RAG answer says no idea, but a systematic evaluation answer says 8.2 out of 10 across 100 test queries. Second question says, did last week's changes improve things? Self-RAG answer, can't tell. Systematic evaluation answer is faithfulness improved 12%, relevance dropped 3%. Third question, which query types perform worse? Self-RAG answer, unknown. Systematic evaluation answer, technical questions scored a 9.1. Conceptual is 7.2. The last question says, are we spending too much on Bedrock? Self-RAG answer says no tracking. Systematic evaluation answer says 0.003 average per query and $45 per day total. So if you think back on what we learned on Tuesday, those are pretty much what we learned was for individual responses. Now it's looking at the overall system as a whole. So it's now taking a look at maybe 100 responses versus that one. So that's kind of how they relate. Systematic evaluation transforms intuition into data so that you can improve your RAG system. And how do you improve that RAG system? By looking at the faithfulness, answer relevance, and context precision. So these 3 metrics capture different aspects of RAG quality. Faithfulness measures, does the answer match the retrieved documents? Answer relevance measures, does the answer address the question? And context precision measures, did we retrieve the right documents? So for faithfulness, failure mode, it catches it are hallucinations and made up facts. Answer relevance catches tangential responses and topic drift. And context precision catches poor retrieval and irrelevant context. A system can score high on one metric while failing another. An answer might be perfectly faithful to retrieve documents, so high faithfulness, but those documents might be irrelevant to the question, so low precision. We have LLM as judge. Uh, we have LLM as judge pattern. Instead of manual evaluation, we will use Bedrock to judge RAG quality. The same models that generate answers can also evaluate them. Why does LLM as judge work? So we have 4 different approaches. We have human evaluation, keyword matching, embedding similarity, and LLM as judge. What are the pros and cons to human evaluation? Pros are it's gold standard accuracy, but it is slow, expensive, and doesn't scale. Keyword matching is fast and cheap, but it misses semantic meaning. Embedding similarity captures meaning, but doesn't evaluate correctness. And LLM as judge is scalable, understands context, but it costs per evaluation. LLM as judge balances accuracy with scalability. You get human-like judgment at API speed. So how do you measure faithfulness? We have a code snippet here that we will be going over. So faithfulness checks if the answer is supported by the retrieved documents. An unfaithful answer contains claims not found in the context. So looking at this code, we have our import for Boto3. We select the runtime. So we're using Bedrock at US East 1. And then we have a function called invoke Bedrock. So this will just handle invoking Bedrock with the query or with your prompt. We're specifying the max tokens we want and then the temperature. So you guys saw this yesterday, response equals Bedrock, or on Tuesday, response equals bedrock.converse. We specify the model ID, the chat format, and then the config, so max tokens and temperature. And if you see the parameters within the function, we're setting the temperature to a default of 0.1. And then finally, we return our response. We're getting the actual text from the output. Now we have measure faithfulness, which is the function that actually calculates it. So measures how well the answer is supported by context. So let's take a look at the prompt. It says, rate how well this answer is supported by the context. And remember, context is all the content within the documents. And then answer would be gotten from this invoke bedrock function. So ideally, it doesn't have it here, but you'd probably put like right before this return line, you do like answer equals response, output message, content, text, and then return that answer. And then the answer would then get sent over to this measure faithfulness function, and it will eventually return a dictionary with your metrics and score. So we went over context and answer. We're also specifying within the prompt to score from 0 to 10, where 10 is every claim in the answer is directly supported by the context. 7, most claims supported, but there are minor unsupported details. 4, mix of supported and unsupported claims. And then 1, answer contradicts or ignores the context. And we're also telling the LLM we want it in a specific format. So the response should have a score from 0 to 10. It should list the supported claims found in context. It should also list the unsupported claims, or if there's none, then it'll say none, and then the reasoning. We set our response variable to invoke Bedrock, passing in the prompt, and then we are setting a default score of 5. if this fails. So if these three lines fail, then it'll just go pass and the score will be set to 5, max score 10, and then we're getting that response for the raw evaluation. So let's actually go over these three lines. So score line just extracts the score from the response. The second line right here is just making sure that what we get back is a digit and removes anything else. So if it says like, if it's a string of score, colon space 8, we're just gonna get that 8. If it says score colon space 8 out of 10, we're still just going to get that 8. It's just getting that exact score. And then this third line right here is just making sure that the score is within the range that we specified, so 0 to 10. And if any of these fails, again, we're setting the default for the score to be 5, so that's what it will return. Any questions on this snippet right here? All right. So this example says context has neural networks learn through backpropagation, adjusting ways to minimize loss. The answer says neural networks learn using backpropagation. They typically require GPUs for training. It got a faithfulness score of 6 out of 10, and the reasoning is the backpropagation claim is supported, but GPUs required is not in the context. Measuring answer relevance. Answer relevance checks if the response actually addresses what was asked. A relevant answer directly answers the question. So we have a function called measure answer relevance. We're passing in a query, and then the answers, again, the answer would come from the from invoking Bedrock. So it's the output, and we should get a output for this specific function of dictionary. So let's take a look at the prompt again. For this specific function, measure answer relevance, it says rate how well this answer addresses the question. So the question, we're passing in the query and then the answer from invoking Bedrock. And we're also specifying the score, what determines the score. So if it's a 10, it directly and completely answers the question. 7 answers the question with some tangential information. If it got a 4, it partially addresses the question, but it misses key aspects. And then 1 does not address the question at all. We're telling the LLM to respond in this format. So again, score has to be from 0 to 10. And then we have an addressed line that it says what parts of the question were answered. We also have what parts were not answered. So if it addresses everything, it'll be none, and then a reasoning. We set our output from invoke Bedrock within this function and set it to the variable response. We're setting a default score of 5, and we see this these 3 lines again, same as above. So again, score line just retrieves that score from the output. The second line makes sure it's an integer, and then we're just making sure that integer is between 0 and 10. And we pass back the score for our relevance, along with the max score of 10 and the response itself from Bedrock. Now, the example for this one says, what causes overfitting and how do I prevent it? The answer says, overfitting occurs when a model memorizes training data. Relevance is 5 out of 10. The reasoning is, it explains what causes overfitting, but doesn't address prevention. Any questions so far? All right, let's go into measuring context precision. So context precision checks if the retrieved documents are relevant to the query. High precision means we retrieved useful documents. So for this function, we're passing in the query and then a list of documents, and then we should get an output of dictionary. Our doc string says measure what fraction of retrieved documents are relevant. We're setting a relevant count to 0 to measure how many documents are actually relevant. And then we have the evaluations for each document that will be stored in this list. So for each document within the total documents, we're going through a loop. We're sending a prompt. So we're saying, is this document relevant to answering the question? We provide our query, and then we provide that specific content of that document as well. On top of that, we add a document is relevant if it contains information that would help answer the question. And we only want an output of either relevant or not relevant. So we invoke Bedrock, passing in our prompt and the max tokens, and we set that to a response. And then this line right here is just looking to see first if the output has relevant in it. So if it does, it's then going to check if not relevant is not in it. So both relevant and not relevant has the word relevant in it. So that's why you also have to add this second part just to make sure that this beginning is not there. So then if it's relevant, then it'll say it is relevant. If it's true, then it'll add a count to our variable up here, to our counter. So then after it checks to see if it is relevant, we will then append it to our evaluations list that includes the document content, so the first 100 characters, and then whether it is relevant or not relevant. So both will get added to that evaluations list, depending on its relevancy or relevance. So this next line right here, precision, is we're just taking that relevant count from our counter and then dividing it by the total amount of documents that we have. If there were no documents, then it'll just be 0. So for this function, we'll return a score, rounding it to rounding that precision score. And then we have that max score of 10. We have that how many documents are relevant, the total amount of documents, the precision score, and then the actual list of the different evaluations. So for the example, it says, how do neural networks learn? And then we retrieved 3 different documents. So it says back propagation adjusts weight based on gradients. That is relevant. Second one says Python is a programming language. It says not relevant. And then learning rate controls step size, which is relevant as well. So the precision score we get is 6.7 out of 10, which is 2 out of 3 documents are relevant. Any questions so far? All right, next up, we're just putting everything together, combine all 3 metrics into a comprehensive evaluation. We have a function called evaluate RAG response. We're passing in the query, context. So again, that's what's stored within the documents, the actual contents of it. We're passing in the answer, so the output from invoking Bedrock, and then the list of documents. And we should get an output of a dictionary again. Docstring says complete RAG evaluation with all metrics. And then over here, this part right here is just invoking all the past three functions that we just went over to get each score. So we will get the score for faithfulness, relevance, or precision. Of course, it'll be the dictionary for each one, along with so it'll have the score along with other details about it. And then after we get those outputs, we're actually going to calculate the overall score using a weighted average. So we're getting the score of faithfulness, score of relevance, and score of precision. We're multiplying it faithfulness and relevance by 0.4, precision by 0.2. And these are for pretty much converting it to percentages. So this is 40%, another 40%. So if you add both of those together, it'll be 80%. And then here's your final 20%. So faithfulness is the most important, relevance is equally important, and then precision is less critical if the answer is good. We will then get returned our query, our answer. So it'll be the first 200, but it'll be the first 200 characters if the answer is over 200 characters. Otherwise, if it's less than 200 characters, it'll just return the whole thing. And then for our metrics within this dictionary, we actually have the score for faithfulness, score for relevance, score for precision, and then the overall score. And again, this overall score, we're adding up all three weighted averages. Finally, we have the details. So what we actually got back from invoking these functions. So these will be the dictionaries. So it'll have the scores for each one, along with the extra details and metrics for faithfulness, relevance, and precision. Any questions so far? All right. Now, for the next code snippet, we have some test suites. So it says systematic evaluation requires test cases that cover different query types and expected behaviors. We have 3 test cases, each with an ID, query, category, expected keywords, and minimum scores, kind of like what we had on Tuesday. So this is just the identifier, our question, what category this is, and then our expected keywords for the output, and then our minimum scores that we should get. Test cases should cover typical queries, edge cases, out-of-scope queries, and queries that previously caused problems. So running the evaluations, we have a function called run evaluation suite. Our docstring says run evaluation across all test cases. And for this function, we're passing in our RAG pipeline, which we didn't have for this lesson, but just think back on day 2 with that self-RAG pipeline. It's kind of doing the same thing. We can actually go back and look at it. So we're just retrieving, validating, generating, and verifying. And we should get our answer confidence, what documents we used, what documents we rejected, and then fully grounded. But for this lesson, it's going to be set up differently. If we look down here, our RAG pipeline will be returning query, context, answer, and the documents. So let's actually start back from the beginning. So we're setting a results list uh, to empty, and then categories, scores, dictionary. So we're going to be looping through each test case, and we're invoking that RAG pipeline, passing in the query from that specific case to get our response. We have evaluation. So we're setting the variable evaluation to invoke evaluate RAG response. So we're calling this function, and it's just gonna again get the faithfulness score, relevance score, precision score, and then the overall score. Over here, we're getting the we're setting the we're getting the query, we're getting the context, and if it doesn't exist, it'll just default to an empty string. We're getting the answer, and if it doesn't exist, we're getting the empty string. And same thing for the documents. If it doesn't exist, it's just an empty list for default. Now, all test cases are going to be the default is they're all starting out as that they passed, so they're all true. But then these two sections right here actually goes through each case and checks to see if if they will fail. So like if there are any failing criteria within those test cases. So the first one is looking at the minimum scores. So it's saying if the minimum score or if the score that was gotten back uh, from the response was less than the minimum value. So say for faithfulness, it was a 6 out of 7, then it'll set passed to false, and then it'll append that metric and the reason for why it failed. So it'll say like, uh, so valuation was uh, 6 less than 7. And then it'll get appended to that failures. Where's it at? Right here. The second criteria is checking for the expected keywords. And it's just looking to see how many keywords were found in the response. If the amount of keywords was, uh, if it only found, if it found less than 50% of the keywords within the response, it'll fail it. And then it'll append it to that failures as well, the reason. So it'll say keywords found, I don't know how many keywords. Let's look at the first one. Expected keywords, we have 3. Say it only found memorize. It'll say something like keywords found 1 out of 3. Next, we're setting the result variable to a dictionary. So this is from what we just went uh, over. So we're specifying the case ID from the test case, the query, and then we're getting the category. If it doesn't have a category, the default will be general, and then it'll state whether the case passed or failed. Again, everything starts out true, but if it meets one of these two criterias, it'll be marked as false. And then finally, we have the metrics. So evaluation, where's that at? So it'll get that it'll put what we found for the evaluation, the output from evaluate reg response, down in this metrics section. And finally, it'll append those results to our list up here. This track by category, we'll just it will take all the scores for each specific category and computes to the average to assign to that category key. So let's see. Does that make sense for this section right here? Any questions so far? All right, and then next up we have calculate summary. So past count, it'll just count how many cases passed. So it'll add up everything that passed, and then we'll finally return the total. So how many results we got, how many passed, how many failed, the pass rate through division, and then the category averages. And finally, we have the list of results. Any questions, comments? All right. So now we have automating evaluation in CI/CD, integrate evaluation into GitHub Actions, so every code change is tested automatically. We have a test file here. So we're importing what we need. So PyTest, we're importing that RAG pipeline, and then that evaluate RAG response. We're setting some quality thresholds. So minimum faithfulness should be 7, minimum relevance should be 7, minimum precision should be 6, and minimum overall score should be 7. We have our PyTest fixture with a function underneath called pipeline. We're just initializing RAG pipeline for testing. So we're returning it. And then finally, we have a class called test RAG quality with a method underneath that says test technical query quality, where we pass in self and pipeline. And the doc string says technical query should score high. We set a result variable to equal to invoke our pipeline with the query what causes overfitting. Then we have an evaluation, same thing as what we saw from earlier up here, where we're specifying the query, getting the context, the answer, and the documents. And we just have some assert lines, just making sure that the faithfulness score is above the minimum faithfulness that we specified of 7, that our relevance is also above 7, equal to or above 7, and then our overall is equal to or above 7 as well. Next, we have another method, test out of scope handled. So our doc string says out of scope query should have low confidence. We ask an unrelated question, what's the weather today? And then it should either refuse or have low confidence. So if the confidence score is low, we're just asserting that it doesn't have. We're just asserting that this test will have a low confidence score, and it'll say either low confidence or don't have information or cannot answer for it. Next method says test retrieval precision. We're passing in that self and pipeline again. Doc string says retrieve documents should be relevant. We specify our result variable, passing in the query, how do neural networks learn? We have our evaluation. So our query this time says, how do neural networks learn? We're getting the context, answer, and documents. And we're just asserting that the minimum precision score is equal to or above 6. Any questions? Actually, let me go back up to uh, measuring context precision and faithfulness, because that kind of gets confusing. So again, measuring faithfulness checks if the answer is supported by the retrieved documents. An unfaithful answer contains claims not found in the context. And then measure context precision says context precision checks if the retrieved documents are relevant to the query. High precision means we retrieve useful documents. So one way to think about that is measure context precision checks the documents and measure faithfulness checks the answer. So imagine a student is writing an essay using research articles. Measure context precision right here asks, did the student did the student pick the right articles to read? And then measure faithfulness is asks, did the student write the answer using only the articles they read? Any questions? All right. All right, so after we went over the test file structure, this is how our GitHub Actions workflow uh, should similarly look. So we named our workflow RAG quality evaluation. It's on whenever we push up to the main branch, create a pull request on the main branch, and then we also have a cron schedule to execute this daily at 6 a.m. for drift detection. So we have one job called evaluate. It runs on Ubuntu. And then these are the steps associated with it. So we have a checkout code step. We have a setting up Python step, version 3.11. We're installing dependencies. And then we're running quality evaluation using our credentials. And yep, Okino pointed out yesterday, if you put this towards the top, it'll be have a different scope, so more global. But since we're only really using it over here, this would be the best case scenario for it. So we're running PyTest. Uh, we're running that file that we saw above, test_quality.py, to test these out, these methods. And then we're storing it in a results.json file. We're uploading the results to the artifacts, and then we're also checking the quality thresholds within a file called checkthresholds.py. So I don't think we haven't, we never went over it, so don't even worry about that part. The schedule trigger runs daily to catch model drift when Bedrock model updates or data changes cause quality degradation over time. So tracking quality over time, sort evaluation results to track trends and detect regressions. So we create a class called quality tracker. We're initializing a file to store our history. So we're naming it quality history.json. We have a method called log evaluation. We're passing in self-evaluation and then commit SHA. And then within this method, We have our entry. So we have times. Let's throw this into ChatGPT and let's figure out what this does. And if you guys have any questions, feel free to just shout it out there. Create a discussion. Uh, we'll better learn that way as well. So yep, the beginning just sets up that history file. And then we have our log evaluation method. So it saves a new evaluation into the history file. That'll include the timestamp of the evaluation, optional commit SHA, the metrics of faithfulness, relevance, precision, and overall score, the pass rate, which is the default is set to 0, the total number of tests default to 0, and it's stored as JSON line, so each line is a separate JSON object. So here's an example of what it would look like. We have the timestamp, the commit message, the metrics, the pass rate, and then the total tests. So if we go back and just look at the code real quick. So yep, it's just creating a pretty much an entry to store within the file that includes these keys of topic, commit, metrics, pass rate, and total tests. Anybody have a question or yeah, any questions on that part? All right. And then this one right here is just opening up that history file and then dumping that entry into there. So that finishes up this log evaluation method. So again, we're creating that entry or that log and just saving it onto that history file. Now for the get trend method. So if there's nothing within the history file, we'll automatically get a trend of unknown and empty data. We set our entries variable to an empty list and then a cutoff of datetime.now dot timestamp minus days times 86,400. So this pretty much saying we only want the logs up to a certain point. So in this case, we set the default to 7 days. So we only want the logs or the entries from the past 7 days. So after we get that, we're opening up the history file again. And then we're just going through each line and entry. And then let's go back to ChatGPT. Let's see what it says. So it looks at historical metric values over the past days. So default 7 and determines a trend. So it reads the JSON history file, filters entries within the last 7 days, and then it'll split the entries into 2 halves. So it'll have the first half and second half. Let's go back to that code. And this is where that is stated. So this is where it gets broken up. And you'll see down here why that is. This part right here is saying if there's less than 2 entries, it's saying there's insufficient data because then, I mean, if you break those two up, it'll just be one and one, and you can't really compare anything and get any useful data out of that or useful trends. Average first. Okay, let's go back over here. So it'll compute the average metric for each half. I was going to do some examples with this calculator uh, uh, for some of the functions earlier, but nobody has a question, so we'll skip that part. And then, all right, so it's just taking the average scores from the first half and then average scores from the second half. And over here it's saying if the average second is greater than the average first, then it's improving. If the average if the average first is greater than the second, then it's degrading. Otherwise, if they're the same, then it's stable. Let's go back over here. So again, we read the history file. It filters entries within the last 7 days, splits the entries into two halves. So the first half and the second half, computes the average metric and compares the two to get a trend. So if the second half is greater than the first half by 0.5, it's improving. If the second half is less than the first half by 0.5, then it's degrading. Otherwise, it's stable. So I guess that makes sense to have that zero point 0.5 part, that difference of 0.5, because then if you have, say, like for the first half 7 and then the second half 7.1, I mean, that's not really a good indicator of anything really.
Yeah, it's so close that I
Mhm.
wouldn't even call that an improvement. That's like stable. It's the
Mhm.
same thing effectively, right?
Yep, exactly. And there are probably some other different uh, ways you can set this up to make it even more accurate, but I guess this is just an example.
Hey,
So
Eric.
yep, go ahead, Troy.
Well, I was just gonna, I'm sorry. The big picture is this is a cron job and it's running against prod every 24 hours.
So yeah, based off of the uh, what essentially I have file name, but I guess what you're referencing is the so this is just a what we're looking at just now is just the uh
The trending,
yeah,
yeah,
the trending checks. But
yeah, for the results.
yep, but for earlier,
The
like
tests.
if we add this file to that GitHub Actions workflow, then it'll run every time we push it onto the main branch or create a pull request. And then also you can specify the cron job to anything, so you can have it set up every at midnight, every day at midnight or daily at 6 a.m. For reassessment. Does that answer your question, Troy?
Yeah, okay. So let's say we don't make any pushes
Mm-hmm.
in, a series of days.
Mm-hmm.
Uh, are we expecting different results outside of the, normal LLM variance?
So if we didn't make any pushes or created any pull requests, then it'll still, since we set up that cron job, it'll still be running every day at 6 a.m. So no matter what, it'll still get ran once a day.
But
Otherwise,
those evaluation scores, are we expecting them to change
uh,
between one day and the next if we don't?
I mean, I guess
N- No,
that
but what if they did? Wouldn't you want to know?
How would they? Like talk me through
Uh,
that.
LLM changes, some dependency that you're not directly coding changes significantly.
so. I believe in one of these past functions or files. I believe they get stored on so for maybe I don't know about this was for test cases. Uh
I don't even know if this can happen, Troy, but what if something in your database breaks and a section of it isn't available for pulling from, and so when it pulls documents from it, it's not pulling the best ones. It's pulling, I don't know, the third tier
Yeah.
relevant ones. And even though you didn't make a single code change, all of a sudden your trending drops, and you're like, oh wow, something's wrong. Not your fault necessarily, but I could see some things outside of your control, outside of code changes that would screw this up. And I guess this is just like cheap insurance to make sure that even regardless of whether it was a code change or the LLM change that you're using under the hood, or maybe something went wrong with your database, you didn't realize that this would surface it really quick to you so you could take action.
Mm-mm. Uh,
eh,
yeah, for some of those things, I just wonder if the merit of the test here, like in the CI/CD pipeline is the right way to capture a prod failure for like a database, right? If we're that's a 24-hour, like and we probably should have some other types of alerts that would capture some pipeline failure, I suspect. Uh, okay, I'm still wrapping my head uh, around this, Eric. So that thanks for humoring.
what other questions do you have?
No, just like test like we're running very standard we're running it through its paces in a very structured manner every 24 hours. If the code base hasn't changed and we're running the same test questions through, outside of checking for failures like Nick was talking about, uh, how are, like my assumption is you're going to lock your LLM version and you're not going to like or you're going to, I guess I don't know how much control we have over the LLM version, which might be a variable then. So, then we're really testing. I could see the testing. But
Yeah,
just the value, like I'm struggling with the value, I guess. It's there, I just don't understand it.
mm, I get I guess you can instead of having like a test file, maybe not referencing this specific lesson with the code in it, but maybe you have another uh you have something set up where it checks each query. So you have something that stores each query made to your system, and then you're checking that. The does that make better sense?
Yeah, I think so. And, you know, Bedrock model updates and data changes. Okay, I think I'm with it.
But also keep in mind, LLMs are uh they're not the most reliable, so of course you gotta like set up you gotta work with it to make it as reliable as possible.
Yeah. Yeah, I think Nick's question of what if it changes is at this stage in my experience with all this as best of a question as ever, and important to safeguard against.
Anybody have anything else to add or any more questions? Any thoughts? Uh, what do you guys think? All right. There's nothing. Let's continue on. But if you guys have any more questions, just shout it out there. Like, it's good to have these discussions so we can try to get to a solution and see different ways of thinking as well. All right. Okay, so we were looking at dividing the or looking at the splitting up the entries into two, so the first and then the second part, and then just measuring them to see if they improved or degraded based on the average score. So we were trying the trend and then the change of the scores, the current average, and then the actual entries stored within the data key. Finally, we have a method called check regression. So we're passing in self, current, threshold, self, current, and threshold. So the docstring says check if current results show regression. We set our regressions variable to an empty list. And then we're going through each of these metrics. So faithfulness, relevance, precision, and overall. We're calling that get trend method to see if there are any trends within the entries. And then we're saying if the trend is degrading and the change of the trend is above the threshold. Does it say the threshold anywhere? Let's see. We pass in the threshold. All right, so from what I'm thinking, this threshold gets specified by gets passed in from somewhere else that's not on this file. If you see something else, just let me know or call it out. So say if mm, you I was gonna say threshold would be 0.5, but oh yep, it is. So the default is 0.5, so it's looking at this right here. So that the difference goes back to that example. If the first half says 7.0 and then the second one is 7.1, we're just specifying how big of a difference must there be in order to really have it count or have it matter. So then if both of those are if both of these criteria are true, so if it's degrading and then the changes above the threshold, we'll append it to the regressions, passing in the metric, the change, and then the current metric. We'll return if it has any regressions, and then the actual list of regressions. Any questions on that part? I know I could probably explain that a little bit better, but is anybody want any clarifications on anything? All right. So next up, we have performance optimization with caching. Evaluation calls Bedrock multiple times per query. Caching reduces costs and speeds up repeated evaluations. Let's have ChatGPT help us with explaining this. So this is kind of what I do too. Like even when you're just working on a project or something, and or you're working on a challenge, make sure to go use Claude or ChatGPT just to explain the code so you actually know what's going on and happening within it, and just get real familiar with it and get a better understanding. So let's say, how does this code work? Let's say, explain how this code works. This code defines a caching system for evaluation results, so you don't have to repeatedly call an expensive function like a Bedrock API with the same inputs. So we have the evaluation class. This class manages a persistent cache on disk using JSON files. We're initializing a folder to store the cached JSON files, and it creates the folder if it doesn't exist, and we just initialize the hits and the misses, so cache hits and cache misses. So that's what this first part is doing. Let's go look further with the hash key method. So the hashing function, it converts input arguments into a unique string, sorts keys to ensure consistent hashing, computes an MD5 hash to generate a unique cache key for a given set of inputs. This ensures that the same inputs always maps to the same cache files. So I guess it's like creating a it's not that dumb, argument, sort keys.
Yeah, basically, if the arguments
Mm,
are exactly the same from a previous run, instead of rerunning, it's just going to pull it from cache, right? Versus instead of just storing the whole thing and checking, it's storing a much smaller hash and then just returning. Hey, if it sees the hash already in its memory, it's like, oh, we've already done this before, and it doesn't have to
Okay.
rerun the whole part.
Yep. So it's like yeah, just creating an identifier for it.
Yeah, yeah, the hash is a unique identifier.
And then so now we have the get method. So it's getting that cached result. So it checks if a cached result exists for the given inputs. If it exists, we increment the hit. So we'll add it to the counter. It'll load and return the cached JSON. Otherwise, it'll increment the miss and returns none. Anybody need clarification on that one? All right, let's go continue. Next up, we have the set method. So it saves a result in the cache for given inputs, uses the same hash key to determine the file name, and stores the data as JSON on a disk. So we're calling that hash key method, setting it to key, and then we're calling that cache directory and uh, setting it as cache file, and then we're uh, dumping it into uh, the uh, the cache file. We're dumping the result into the cache file. Statistics. We have the stats method. So we're adding up the hits and misses and then returning dictionary with the hits, misses, and then the hit rate. self that hits over the total. If there's no if there was no hits or misses, it'll just be 0. And then we have the global cache. Where's valuation cache come from? Let's see. That's just the class. And then we have a function called measure faithfulness cached. We're passing in the context, the answer, and for our docstring, it says faithfulness measurement with caching. Check cache. So cached equals eval cache. We're using that get method, passing in faithfulness, context, and the answer. If there is a cache, then we return it, and then we're calling the measure faithfulness function, passing in the context and answer to get our result, and we get that cached result, and we use the set method this time, passing in that result along with faithfulness, context, and answer to return the result. Any questions? I know I could probably word this better and clarify it better. All right. Next up, we have cost tracking. So we have a class called cost tracker that estimates and tracks cost of using AI models. So specifically, we're using Nova Lite, Nova Pro, and Claude 3 Sonnet. And then we're storing the costs per 1,000 tokens for each model. And then costs differ for input tokens and output tokens. Then we initialize total costs and calls, set cost to 0, calls to an empty list. Total cost is the cumulative cost of all tracked API calls. Calls is the list storing details of each call, model, tokens, and cost. We have a estimate tokens method. So we're estimating the token count. We're roughly estimating that 4 characters equals 1 token. So we're getting the length of the text and dividing it by 4 so that we can get how many tokens are in that text. Now we have a track call method. We're passing in self, model, input text, and output text. So for the model, it's the name of the model used, input text, text sent to the model, and then output text, text received from the model. Steps are looks up pricing for the model, defaults to Nova pricing if unknown. Let's go back to the code. And then it estimates the input and output tokens, computes cost, adds the cost to self that total cost. And then it logs the calls with details, some models, tokens, costs, and self.calls returns the total cost of that call. We return the total. We have another method of summary. So it says get cost summary. So we have the total cost rounded total calls. So the length of the calls within that list. And then average cost per call. So we're taking that total cost, dividing it by self.calls. If there's no cost, it'll be 0. We have a method called estimate monthly. Docstring says estimate monthly cost based on current usage. So if there's no calls, it'll return 0. Otherwise, average cost will equal the total cost divided by the calls. Some 3 evaluation calls per query. And then we have a variable called daily cost. And we're multiplying queries per day by 3. And also the average cost. We returned daily cost times 3. Rounded. And then we have a class that actually puts everything together. So we have we're initializing the pipeline, the cache, the cost tracker, and then the quality tracker with the different classes we just looked at. We have a evaluate query method. So we're passing in the query to the pipeline, getting the faithfulness, relevance, and precision. With the caching, and then we're calculating our overall score again to return the query and our metrics of faithfulness, relevance, precision, and overall. And finally, we have a run suite method that runs the full evaluation suite. So run evaluation suite, where's that coming from? That's running the evaluation across all cases. Okay. So for the evaluation, we're passing in our pipeline and test cases, logging our results using quality tracker log evaluation method, passing in our results. We're checking for regressions. So quality tracker class using the check regression method, passing in the results. And then we're taking those results and then also, so we're unpacking those results, checking, getting back the regression, the cache stats, and the summary of the cost tracker. So overall, summary is we looked at different components, the faithfulness metric, relevance metric, precision metric, test suites, CI/CD integration, quality tracking, caching, and cost tracking. So our first component, faithfulness metric, check answer matches context is the purpose. Key benefit is it catches hallucinations. For relevance metric, it checks answer addresses. Check answer. We check that the answer addresses the query. Key benefit is it catches topic drift. Third metric is precision. So we're checking retrieval quality. Key benefit is it catches poor retrieval. We have our test suites. Purpose is for systematic evaluation. Key benefit, reproducible quality checks. We have our CI/CD integration. Purpose is automated testing, catches regressions early. Quality checking. Purpose is historical trends, detects drift over time. We have caching for avoiding duplicate evaluation to reduce cost. And finally, we have cost tracking to monitor spending and optimize our budget. Systematic evaluation transforms RAG quality from guesswork into engineering, measurable, trackable, and continuously improving. So a quick reference for our 4 different metrics. We specified our score ranges from 0 to 10. We set some thresholds. So for faithfulness and relevance, plus overall, it's 7. For precision, it's 6. And for faithfulness, if it's less than 5, it indicates hallucination. If it's for relevance, if it's less than 5, it indicates topic drift. For precision, if the score is less than 4, it indicates retrieval problems. And for the overall score, if it's less than 6, it needs investigation. So that is the end of our lesson for week 22, day 3. Let me go ahead and stop the recording.